Hello, hello.
Virus is coming through.
Virus is coming through. Frank 2, what's going on, baby? And now we have the table. Not for flipping this time, I promise. Well, maybe. Just stop. That, okay.
You're going too far.
You've crossed the line. That's good, yeah. All right. So, ready to get started?
Yep.
We're ready. We're gonna talk on things. Oh, look at him, but understand me. So, if you don't know, we're dc949, and we fuck around, but not really. We don't fuck around. Yeah, fine, fuck it.
We don't fuck around when we fuck around.
Exactly, we don't fuck around when it comes to fucking around. So, has anyone watched the Layer 1 talk from a while back, a couple months ago? So 2, 3, 4, half the audience. Got it. So, this is the next steps of what we did after that talk. We're going to go over a couple of the same things, but mostly it's going to be new and unique content. With that being said, let's get started. If you don't already know, I'm CP. This is Adam. This is Jeff Bull. And let's get started. Next slide.
Talk louder.
Talk louder.
Nice.
That's you.
That's me. So, does anyone not know what a CAPTCHA is? Good. Next slide. All right. So, we didn't really just decide one day that we were going to break reCAPTCHA, but that's kind of not true. We basically did just decide to break reCAPTCHA one day. But there's a reason for it. Initially, there was a Twitter contest at ShmooCon where if you had the most followers and you tweeted a certain thing, then you would win an iPad or a television or something. And these guys decided that they wanted to do that, and all they had to do was break reCAPTCHA to make Twitter accounts. How hard could that possibly be? Well, after a couple of days of working on it, they're like, you know what, let's just do this later. I had recently moved to a new state, and I was kind of bored, and I said, what could I do to have some fun? I know, I'll break reCAPTCHA. And about a week later, I found out that they were also working on breaking reCAPTCHA. So we, of course, joined forces, because that's what we do, and we rolled out this fun shenanigans. Fucking Christ. So, yeah, go ahead and play it. Do a sound check real quick.
Vote 8. Vote 8. 4. Ferry.
Anyone hear that?
Wednesday. Cup.
Iron Gate, can we get some louder sounds?
Sound up.
Audio out. There's no audio out. We don't have audio out for that.
All right. Well, what you would have heard was the initial version of reCAPTCHA that we broke. If you are interested, go watch the Layer 1 talk on YouTube. There's 58 words. They're all basic words like boat and kitchen supplies, like kettles and pot and table and, just...
I can see what.
Vote 8.
And the whole caption was just 6 words, took about 8 seconds, and then it was over.
Wednesday. Cup.
It was just quiet. No big deal. Next slide.
Loud now.
Too little, too late.
Yeah, well, there's more later. Okay, so this is for the first version. We're going to go over that, and we are. This is spectrogram. What it is the frequency versus time, and the darker it is, the louder it is. So this is the loudest part down here at this frequency. But what you'll notice is the background noise, which is this, was not at the same frequency range as the words. So if you're trying to pick out the 6 words in that, can you see where they are? So yeah, that was kind of easy to split. The next couple rounds, a little bit harder, but this one, super easy to split. Just look right there. Ding.
All right, so we took all that data, and we had our individual words, and what we needed to do was categorize them so that we can associate, okay, if the data looks like this, then it's this word. If the data looks like this other thing, it's that word, and so on. And we had a few different solutions in the beginning, and then I just got the idea, well, why don't we just throw it in a neural network, have that sort everything out, and then, we'll have all the answers. So we decided to go ahead and do that. Question? Single layer. We'll get to that. So machine learning the neural net, the machine learning we were using is supervised. It's a neural network. It is similar to linear regression for any of you who know much about machine learning. There's a lot of linear algebra, matrix math, calculus, all kinds of really cool math stuff. And there's not really enough time in an hour to explain how neural networks work. But that's what we use to solve it. So this is how our neural network works. You can see a nice little diagram there. The left-hand side is our inputs. So we'll have how much basses are in the audio sample, how much mid-range, how much highs. And instead of having 3 bands, we have 2,048 different bands. And that just tells you kind of what the word sounds like, but it's all done in numbers instead of, humans listening to audio. We have 1536 hidden nodes, which I'll get to in a minute. And then since there were 58 different words out of, we knew that every sample is going to be one of 58 words. So we have our 58 different output nodes. They are correlated with one word. So the first one might be red, the second one's blue, train, etc. Boat. Yeah. So next slide. So this might be the word red, and we solved all these by hand first, so that we knew, okay, this word is definitely red. And then you look at the spectrogram, and you have not a whole lot of bass, a bit more mid-range, and quite a bit of highs. The next word is blue, and you can see it's a little bit different, about the same amount of bass, similar mid-range, but not so much in the high end. Next word is green, and you notice the high end drops way off there, but everything else is pretty similar to blue, more or less. So, yeah, and let's say we get another word, and this is one we don't know what it is. So this is unlabeled data, and can anyone tell me what word they think that is, if it's either red, blue, or green? Black, wrong. This is one of those 3 words. Red? Yeah, it's closest to red. So what you basically did there is you just take the difference between the black and each one of the other characters, and you add it up and you see how much error rate there is. So how far off is it from each of these different colors? And then you pick the one that matches best. That's simply how the neural net works. It just says, how well does this unknown word match each one of the words that we know about? And then it just picks the best one. So we won't have a 100% match, but we'll be close to it. Next. So when we're fitting this word, we need to draw a line that goes through each of those points as best we can. And then we measure against the line instead of each individual data points. The reason we do that is we're going to have a whole bunch of different samples of red. So we're going to have some that are a little higher pitched, some have different background noises in them, stuff like that. So they're not all going to be identical. So what we're going to have is a whole bunch of different samples of red, and then we try and draw a line that fits the data as best we can. This would be one way to do it. It's just a straight line, and that might fit, well, nothing very well, to be honest. So next one. We could curve it a little bit. That's a little bit better fit. Still pretty far off on that middle column, though. Next. Okay, so we're getting a little closer now. That's actually looking pretty good. And we could just go all out and say, oh, well, look, that line fits all of our data. Isn't that great? And that works extremely well for the stuff that we trained it on. However, some new sample that's not quite perfect, this is going to be, you just look at that and you're like, well, I don't think that's really a good representation of what red looks like. That's kind of silly, is the bottom line. It fits really well, but it's contrived. It's all, it fits this sample well. It doesn't generalize very well. Exactly, we made it up. And if we get the exact same sample again, it'll match perfect. But for any other red that has some background audio in it, it's not going to match very well. Next. So those different squiggly lines are all valid options. and it's hard to know which one's best. Like in the samples I showed you, obviously the first and the last ones are not optimal, but the middle two, which one's better? Well, it's hard to say. That's where the hidden nodes come in. Basically, each one of those hidden nodes is like a different line that we're drawing through there. So they're all squiggly and they're all a little bit different, but they're all similar. So what we do is we use some linear algebra to get from the input nodes to a hidden node. And then we use that same math to get from the hidden nodes to the output nodes. And what the output nodes are going to have is a combination of all these different squiggly lines and says, well, how well does that match the word red? And we get, we're getting like 90 some odd % that we're sure that it's red, and like 0.2% sure that it's blue. So we just take those numbers and we say, okay, well, the highest probability is red, so we'll pick that. Next.
Oh, yeah.
There you go.
All right. So for our first round, that we got 99.1% accuracy using that splitting and then the machine learning solver. 99% accuracy, a lot of them. So very accurate. Not much more to say about this slide, but it worked out really well. Ding. Oh, yeah. And then the interesting thing is they rate limit you if you get less than 60%. But after you get more than that, they'll just let you go as fast as you want. And so an 8-second CAPTCHA could be answered in half a second, and it'd be all right. So pretty bad Turing test.
We are as human.
Yes, we are as human. Oh, yeah, this is a good one. So the other thing that we noticed was there's only so many CAPTCHAs. There's a set number. That set number was between 20 and 25 million, but there's a set number. And so if you just have a lookup table of MD5 to answer, you could solve the CAPTCHA in rather than 0.5, 0.005 seconds. And so you just have to pre-solve it and then ask Google if it's correct. If it's correct, you save it. And so we did that for 15 million CAPTCHAs. It came out to about a 500 megabyte file that was just answers. Yeah, and so if they had rate limited us, we probably couldn't have done 15 million in a month and a half. Yeah. And that's 15 million unique. We only recorded unique ones because we already had the answers for everything else. So we were doing like 2 million a day between all our servers. Yeah. Oh, and 15 million gives you 61% accuracy just using the lookup table. Yeah.
They can't hear you.
Anyway. Oh, so yeah. And that was everything we did prior to last talk. And now, if you saw last talk, this is going to be the interesting portion for you. It's all new stuff.
It's not so much a prerequisite as maybe just an experience to go and view our talk from the layer one. We went over a lot more detail of the initial round, and we had a lot of fun doing it because I don't think we mentioned in this one, but an hour and a half before our talk, they patched it. Yeah. So it's not like we were being stealthy. Millions of CAPTCHAs solved a day. And we've been trying to open a line of dialogue with them since that happened, and it just seems that Google and reCAPTCHA guys don't want to talk to us. And I can't imagine why. But once again, come on, let's have some drinks. Let's talk about this. It's fun. But they don't want to talk to us. Who's doing round two? I'm doing round two. All right. So round two is the digits. The digits. All right. Let's listen to round two.
7, 5, 4, 1, 7, 2, 9, 4, 7.
All right. If you could actually hear that, maybe in the front, good, maybe not in the back. It's 3 sections of 4 numbers. So it'll be like 7, 4, 2, 1, and then a pause, and then another set of numbers, and then another set of numbers. This is a really weird move, and we didn't really expect this because they've done only digit CAPTCHAs before, and it didn't end too well. Before we broke it, someone else broke it because they only used numbers. And here we are running back to using numbers. Yep.
So the thing they were hoping for is that if they smatched all the words together, like these 3 sections of 4 really quick digits, then we wouldn't be able to split it. And so it would be really hard to split, and then since you can't split it, you can't solve it. But then CP had an idea.
Explain.
Wait, explain.
Oh, all right, yeah, sorry. Once again, this is a spectrogram, frequency by time for round 2. And all this stuff right here, you'll notice it's not as dark as the orange right here. This is where the actual words are. And so you can see the 3 groups of 4 digits each. But you look in there and you can't really split the digits up too well. It's pretty hard. And so that's where CP's idea... Oh, all right. My idea was you take each one of these orange lines and then you try and group all the orange, that orange spot, and then this orange spot, and that orange spot. And sometimes they bleed together, and sometimes they don't touch, sometimes they do. So I had like 700 lines of code to try and do this, and it was working marginally well. And then CP had a much better and simple idea.
For like 3 days, I'm saying, why don't we just do this? This one thing is so easy. Let's just try it. No, that'll never work. That will never... Now I'm doubting myself. That could never possibly work. Let's just take that chunk of audio and cut it into 4 even pieces. Fuck it. So, here's the fuck it splitter, where we take those chunks and we just cut it into 4 even pieces. And I think what I've learned through this whole experience is that neural networks and machine learning in general is the closest thing to magic that science has invented. And back in round 1, we were initially trying to remove the background audio, the fuzzy kind of background, backwards radio broadcast to kind of break up your ability to speech to text it. And we're looking at how do we remove that audio? That's tough. And we thought, well, why don't we just not bother? Why don't we just ignore it? I mean, that's what humans do. We don't really listen to the background noise. There's a hiss in a room and a general conversation in the next room over. You're not really listening to that. You're listening to us up here. You are able to parse it out. Why can't we just do that? And it turns out we could. We didn't do any kind of noise removal for round 1. Or round 2, or ever, basically. So the fuck it splitter, never thought it would work, and it turned out it did and saved us a bunch of trouble. Really funny, I think.
So there is some bleed over from one digit to another, but the neural network still works. Same as before. Didn't change any code. Like the actual code is identical. All we changed are the number of we didn't even change the number of hidden nodes. We changed the number of outputs because there was a different number of words. 10 instead of 58. And this is their improved system, right? Brilliant. Ding.
So, I don't know who's supposed to do this slide. Is that me or you? Fuck it, I'll do it. Round 2, we got 63%. And honestly, that's because we just couldn't be bothered to work it back up to 99%. Because we didn't really change anything. We used the same code. And we said, oh, we broke it again. That's neat. And it was live for about 28 hours. And compared to the previous negative 1.5 hours, I'd say that's an improvement. And they rolled a different version out. Which we promptly broke.
Yeah, and if we just got more samples, we could have got.
Oh yeah, and just more samples typically means more accurate, and we didn't really feel like solving 150,000 samples again like round 1. But don't worry, there's some interesting improvements we'll go over later about that.
Oh, no, this is you.
Oh yeah, so remember the whole MD5 thing, limited number of captchas? Well, in round 2, they stuck in ID3 tags, what looks like something, and it turned out that all we could figure it was for was to keep the MD5 sums of the MP3 files from matching. So you just remove them, and they match again. So,
Nice try.
Really? Like, all right, next slide. Round 3.
So round 2, yeah, this is the ridiculous one. On round 2, we released June 30th, and then Round 3 we released July 4th. And so the reason that is because round 3 is actually round 2, but this is the version that they switched to right before our talk, our last one. And so then right before we broke this, we were about to release this version, they switched versions to the digit one. And so then we looked at that and we're like, no, they couldn't have done that. And so we broke that real quick, forcing them to go back to this version, which we had a break for already. And then we released that. So yeah, this one was on the 4th, and it was live till the 7th. So yeah.
Again, an improvement.
Yes, this time it was for 3 days and 5 hours or something like that. 59 words.
Kill it. I'm done. Oh, God, I can't listen to that anymore. That will send you into the madhouse. All you got to do is validate a couple samples. Just validate a couple samples. A couple thousand samples. I'm actually thinking about trying to start a study to see how fast we can drive a person insane by forcing them to listen to reCAPTCHA. And that's great. That's not even the current version. Just wait.
Oh, all right. Well, that was a ding. So now you'll see the spectrogram. You can't even see where the words are supposed to be. Well, all right, you can a little bit, but not nearly as easy as round 2 or round 1, obviously. So then we're looking at this. We looked at it for a while, tried a couple different things, and then we noticed, hey, what about down here? And so just the low end of the spectrogram. Ding. So yeah, look at the low end of the spectrogram. Can anyone see where the words are in this one? The orange parts. Yeah, actually, this one we had to solve. I think we trained before they switched it like 600, and then we did another 800 CAPTCHAs. And so this one ended up with we solved it with about 1,500 samples. Yeah.
With this version that was really annoying, and you just heard a second ago, humans were able to get about 30%. Kind of industry standard is humans should be able to solve 70% for a decent CAPTCHA system. If they can get better, then that's cool. And it should also stop bots from getting it at least less than 1%. The bots should be able to solve. So those are the kind of metrics that are kind of industry standard across all CAPTCHA systems. Theirs did not live up to that, and we still beat it. So,
anywho, so this is the spectrogram with a high-pass and low-pass filter to filter out everything except for 80 hertz to 160 hertz. And so then you get a picture that looks like this, and you can just easily parse this by looking for the orange sections, and that's where the words are. So, very easy, wasn't perfect, but it still beat it good enough. Oh, Adam?
So after we split it, neural network, same shit, different day. Nothing, like we changed the number of output nodes again, and that was our code changes for the neural net. Like he said, black magic.
So this one went live July 4th, about midday. Our test run, we did about 1,500, got 911. That's 59.5% accuracy, which is... What? Sure, I don't know the reference. But yeah, 60% accuracy, better than humans could have done. And once again, we were just trying to release quick. We probably could have done more CAPTCHAs if we didn't go insane and get back up to the 90-some-odd% accuracy we would have.
Same thing as round 2. It's not that 59.5% was the best we could do. It's just we got bored and we're like, yeah, we'll just fuck it. Just get it out there. But we'll just wait for them to fix it and we'll just fucking do it again.
We were also kind of hoping they didn't have another CAPTCHA system on standby, because like they did for round 2, they had one just sitting there. For round 3, we were hoping they didn't. Oh, yeah. This happened again. We released the code that says, and a nice comment of, remove the ID3 tag and it's lols again. And they didn't fix it for round 3. Oh, yeah. So, go for it. All right. So, round 4, the current one.
Yes, please.
Yes, listen to this one. This one's great. Yeah, so we're coming up with the number of words. Right now it's question mark, and no one knows what they are. There's one that's like black or block or bleh. All right, down here. So
let's just put it this way. After the last couple of months of us three doing this, if there's anyone in the world besides spammers and crackers and I'm making money doing that stuff, if there's anyone in the world that could solve this by hand, it's the three of us. And we can't. It's so completely, utterly borked. The joke so far internally has been that we defeated it. They broke it.
So yeah, round 4, current version, 6 to 12 words, between 16 and 36 seconds long. And I tried 30 of them, and between the three of us, we've done 60,000 CAPTCHAs.
The old ones.
Oh, yeah, well, between all three systems, we've done 60,000 of them. I got 0 out of 30. You have a 30-minute time limit for each one. I loaded up in Audacity and sat there for like 10 minutes just replaying it. And I'm like, all right, that is it. Google told me, no, it is not. So, yeah, it's pretty hard. Ding. Oh, yeah. So this is kind of funny as well. This is the low spectrum splitter again. It's 80 to 160. Or no, this one's 0 to 200 hertz. I changed it a little bit. And so you look at it, they must have looked at our code and thought, oh, they're looking for the orange spots, so we'll add more orange spots. That way they'll never get it. Ding. Unless, of course, you do a SOX noise reduce, in which case... So, SOX has this great little ability to remove noise, such as all the stuff they tried to add.
In one command.
Yeah, one command that runs in about a quarter of a second. So that's a word, right there's one. It goes on, I had to actually crop this picture. It goes on for 36 seconds, but it's pretty easy to see where all the words are. Some things like this is a compound word, so it could be like bookshelf, and then each one of those parts. But you can look for how close the words are and combine them into one. So it's not very hard.
The amazing thing is, even though we know where the words are, and we can reduce the noise, we still can't understand what the actual words are, even when we're cheating.
So, if anybody knows how to solve these and can give us somewhere...
Oh, we have a volunteer.
So, background, my career is in linguistics. So, the guy who was the professor for my phonetics professor is a guy named Peter Ladin. He's dead now, but he used to be like an expert witness at trials looking at spectrograms that like the cops had recorded from wiretap calls and saying, yes, this guy is the same answer is not, the same guy as the guy in the stand. You can also, he was also interested in spectrograms just like we were talking English because, as it turns out, there's a ratio for basically every phoneme of...
Can we get a microphone over here? I mean, we might as well. Come on up. Yeah, come on. And this is how we do things. You pour her a drink, please.
Drink.
So repeat everything you just said, and welcome.
Okay. All right. So I used to do linguistics in grad school. And the guy that was the professor for the professor I took phonetics from is a guy named Peter Ladefoged, Ladefoged. He would do stuff like, be an expert witness at trials where he would have to identify whether the guy on the stand was the same person as the guy whose voice was on this wiretap by comparing their by comparing the spectrograms of both voices. He also could read spectrograms like they were English because, as it turns out, what you see on that spectrogram, for every phoneme in a word, there's essentially a ratio between sort of where the formants, the bright lines, fall. And so when you learn to recognize those ratios, you can pick out individual phonemes. And I think you could really drop the size of your feature space if you were to essentially do just sort of a rule-based principal component analysis.
You are 110% correct, but that's more work.
Yeah, but it's work I know how to do.
Very true. So
We don't.
I forgot to preface this talk by saying we don't know what the fuck we're doing. We've never done audio analysis or machine learning or neural networks or any of this crap. We were bored. But you're right. We've thought about a generalized phenome system that will just detect the phoneme, phenome, pheromone. What's interesting about the current version is that the background noise and the foreground noise seem to have the same amplitude and seem to have been used from the same text-to-speech synthesizer. So while you may hear a correct word in the foreground, like snowflake, you might also hear fucking bookshelf in the background with the same exact speech-to-text synthesizer. So it's really hard to do that. And by all means, like let's talk after this. I think that let's break it again because we just keep doing this.
Yeah, no, I think the amplitude dropout thing that you're doing is going to end up completely correcting for that. The SOX noise reduction thing. Yeah, no, I was writing that down in my notes going, I hope they're doing this, and then boom, next slide.
So, we just kind of did some other things, which we'll go over a little bit later in the talk. A quick bit, 'cause I think we're running out of time. But we're just kind of holding our horses until Google releases the next version, because there's no way in fucking hell that they're going to be able to keep this version around, considering all of the complaints they've been getting. Their forum, their Google group on reCAPTCHA is absolutely stacked from top to bottom with things like, oh, you guys are terrible, worst shit in the world, and ADA complaint and this and that. And we're just like, tee. So we're just waiting for them to release a new version, and then we'll break it again. But you know what? I actually hope they do one thing. It's one thing we put in our last release. We said, unless you change a significant amount of how audio CAPTCHA systems are built, Stillwalker's going to steamroll them every time. What do we do to piss off Eric Schmidt? I don't know. But, I'll say it again. I said it at the Layer 1 talk. They got us so good releasing a new version an hour and a half before the talk. That's awesome. It's such a dick move. It's exactly what I would have done.
So yeah, we beat them in, our one version 28 hours, and then the next one 3 days. So yeah. Anyway, moving on. Ding. Oh yeah, and so after we couldn't solve any of the reCAPTCHAs, we had it split, and we have a solving method that'll work. We just can't get sample data. So what are we going to do? We got bored, and so we found all this other stuff like new CAPTCHA. And we're like, oh, these are terrible. So yeah, play it.
Please type the letters 9, Z, V. Once again, 9, Z, V.
After you heard round 3, and then you hear this one, and we broke round 3, so why couldn't we break this? So we did. Now go back. I wasn't done with that one. All right. So they have some type of behavior analysis, which is hilarious because it's all client side, so you can lie to it, and they won't ever know. All the form fields are like, when did you enter the text box? When did you leave? You can just fill in what the normal amount is, and then they will never know to give you a different one. But if you spam them really fast, they'll start giving you different number of words, so they start off with 3, and they get up to a maximum of 4. And so it gets really hard when you have to do 4. To be fair, they may have done more, but we answered enough, so no. They may have done more, but we answered them correct enough that they thought we were human, I guess. So maybe it would get up to 7 words, but it didn't for us. Oh, and they repeat them twice, so you get 2 samples, which makes it even easier. All right, now Dan. Oh, yeah. The splitter, low spectrum splitter again. This first part you see here is please type the words. Then word, 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 and then once again. And then I cropped the rest of it, but on the other side there would be these 3 words repeated again. So you can pick out all the words. You have to know to start 1 1/4 seconds in, and just go until you see a bunch of words that are close together. Not very hard. Oh yeah, and Adam?
Neural network, same shit, different CAPTCHA.
Well done, sir.
Oh, so our test run here, it's a little bit annoying to test because the hilarious part is I don't know if they're trying to protect their CAPTCHA by not giving them out a lot, but each site only has so many CAPTCHAs that they will give out. So, and you'd think that normal would be nice and large, like Google's 25 million. It's about 1,000, less than that. So each site, if you solve 1,000 CAPTCHAs from that site, that's it. And so they just keep giving you the repeats. And so once you've solved 1,000 of them, or it's much less than 1,000, I just say that to be generous. But once you solve them all, you never get a new one. And so you just keep going. If you wanted to spam a site, you could spam it all you want. Oh yeah. Anyway, yeah, our test run was that. Demo time. Demo time.
Demo?
We have plenty of demos.
Oh God. So I don't know if those of you who saw the layer 1 talk, considering the fact that they fixed it or broke it, depending on your point of view, an hour and a half before the talk, our live demo failed. But of course, we took a video. As everyone who gives a speech or talk or rant or drinking in front of people should know, always take a video of your demo because shit gets fucked up a lot.
Please type the letters J, T.
So here's the new CAPTCHA demo.
Once again, J.
So,
T,
because they only give out so many per site, including their demo page, we got from their demo page, they only give out 250. And we need ones to train on. So their demo page gave us 250. And that was it. And so if we were going to... Yeah, I know. If we were going to test against the demo page, we trained against it. And
once again, K, 0.
And so you can't test against the same data you trained on. That's kind of cheating. So we had to go to somewhere that wasn't their demo page to test. So sorry, that site, you were the top at the Google list for the search powered by new CAPTCHA. So you may have a lot of comments that look similar.
We really should have censored that website name. There you go. Good. Now just hold your arm there during the demo. Well, here's who. Oh.
That's the best.
So new CAPTCHA is pretty interesting. They actually came out with a pretty novel concept of how to beat image CAPTCHAs. They've got dancing red letters in an animated GIF, except you can just take the first frame of the GIF and you have a still image. And then you can take the next frame and you have another image. And you can do the next frame and you have another image. So you have, 30, 40, 50 times more data than a regular CAPTCHA to break.
We gotta get going. We got 20 more minutes. All right, so we're going to move faster because we only got 20 minutes. Anyway, that was new CAPTCHA. They only give out 250 on their demo site, so we had to test against something else because we got 99.5% accuracy against their demo site since that's what we trained against. So, yeah, but then they just gave us the CAPTCHAs we trained against. Anyway, ding. All right, oh yeah, and like I said, you can just MD5 solve this because there's only like 250 to 1,000 per site. And so if you wanted to attack a specific site, you solve 1,000, you're done. Ding. Oh yeah, and then there's more. No, PayPal, because they were awful. It's 31. It's digits and letters. Oh, demo time. Oh, listen.
It's muted.
Stop doing that.
JN7NT.
It's 5 words. Used a fuck it splitter, which CP came up with, which is awesome. And then
Neural network, same shit, different caption.
anyway, next slide.
Back forward. There
All right. Yeah, so that's the accuracy, and that was our test run. Now we're going to do a quick demo. Hold this.
Yeah, go ahead.
So, maybe PayPal wants to have drinks with us. Yeah? Or new caption. Or, I don't know. I mean, new caption seems kind of boring. Dancing red letters? Are you serious?
Yeah, so I didn't make a Selenium version, but this is Bash. It downloads it with curl and then submits it with curl because we're lazy. You can actually notice each of them, they get solved in less than a second, which is funny because they take way longer than that to play. But yeah, 3 out of 3, and it's going to keep going. We ran it for 2,000, and it got 95%. So PayPal, hooray. Yeah. Oh, yeah, we tested against their forget your username, and if you just fill in a username that doesn't exist, then they'll still tell you whether you got the captcha right. So we didn't actually have to make new PayPal accounts every time, like some other things. Anyway, I think you're next.
I'm always next. Secure image. This is fantastic. You and me. Well, we were, we actually were like, all right, so we got reCAPTCHA, and that's broken, so we'll wait for that. And we got new CAPTCHA, and we're just like, all right, let's just Google for audio CAPTCHA systems. And we found this guy. And this guy's pretty funny. This guy apparently sells to things like government agencies to have CAPTCHA systems. And their audio, well, I mean, I think you can kind of guess what happened. What happened?
So yeah, it works really well. So this one is actually an PHP site. You can get in Apache. So rather than having to solve them, I just generated a bunch of captchas, and we use that to train. And so then you use the fuck it splitter, and
T 5 K L 5 G.
Yeah, so the neural network tears it apart, as usual. Same shit, different captcha.
we have a demo for this one. Once again, more data would equal better accuracy, but I couldn't be bothered to solve it again. We don't have much time, so we're going to skip this demo because we got a lot of stuff.
Just roll through it. We just roll through it. We just keep going.
Oh, this one's funny. This is you.
What's me? Fuck, what did I do this time? Oh, Slashdot. All right. So while we were just kind of dicking around and looking at capture systems, I had remembered that we were watching Slashdot because, like, oh, cool, a Stillwalker article on Slashdot. We're cool and neato now, and people like us because we're on Slashdot. So, and I realized I saw that they had an audio capture system. I'm like, yeah, all right, let's look at that. And it's good. In fact, I would say Slashdot has done more to increase the vocabulary of users than any other audio capture system, which really isn't that big a claim to fame. We're going to play it.
Prosper. Prosper.
So it not just says the word, it then spells it. But the vocabulary it uses is rather intelligent. We don't want tards talking on our comment forum like it's /B, which I love. It's cool. We didn't do nothing. But I decided that we should take a little bit of a different approach because we've already broken audio capture up, down, left, right, A, B, B, and star select, which I fucked up because we always talk while drinking. So we remembered that a while back I was playing around with this Perl script that takes some audio and submits it to an API that converts sound into text. So speech to text. And this API just happens to be owned by Google. because it's their Chrome API. So I guess if you have Chrome, I've never actually used it, to be fair, you can do speech-to-text things like go backwards in the browser and find my porn. But maybe that's unrealistic because I've fucking never used it. But we found the API. We have a Perl script that submits to it. We actually just download the audio from Slashdot and pipe it directly to Google. And Google says, I think that word is banana hammock. And we just take banana hammock and pipe it right back to Slashdot. And it works. The interesting part is the API actually spits back information, things like confidence. And because it spits back confidence, it seems like they're using a neural network. So we couldn't even be bothered to do Slashdot because, quite frankly, I love Slashdot. I wouldn't want to submit spam on the forums or spam on the comment sections just to test our shit. It's the actually only thing that we didn't bother to religiously and violently poke. Slashdot got solved, go back, with 56% we didn't even do anything. We just sent it to Google and they're like, yes, that is this answer. So the API solver is also included in the next Stillwalker release because, as it turns out, it doesn't just work with Slashdot. It works with other shitty audio capture systems like this guy. In fact, I mistakenly spoke earlier. This is the guy.
What? Yeah.
Yeah, this is the guy that apparently solves the government agencies, their audio capture system. And the Chrome solver gets 99.95% accuracy.
Please enter these four numbers. 6, 4, 0, 6.
No background noise, no nothing, just really clean. This guy probably recorded it on his MacBook. 6, 0, 5, 7. But, shit works. Go figure. So, obviously with 4 digits, there's only 10,000 possible CAPTCHAs, and MD5 solver comes back into play, and that's game over again for this one. We actually ran out of audio capture systems to fuck with. So if anyone knows a different audio capture system, talk to us and we'll get back to you like in a couple days. A couple hours maybe. I mean, it really comes down to. Oh, so this is really fun. Yo, dog, we heard you like artificial intelligence, so we put some genetic algorithms in your machine learning so you can evolve while you're training. We decided that at some point that we got tired of solving thousands and thousands and thousands of CAPTCHAs. And we said, all right, let's take a step back. Let's look at the whole picture. What are we playing with? All right. Fuck that. I am tired to hell of listening to capture systems. Let's just create a genetic algorithm that trains the neural network and increases its accuracy after a base set of just a few. So we solve a couple, and we give it to our genetic algorithm trainer, and it goes, oh, I'm going to train a neural network. There it is. It's higher accuracy than the previous revision. And that just keeps trucking along day after day. Next slide will explain more. That's you.
So we got this flow chart that it's probably hard to read for the people in the back, but start here. Just continue until you've got great accuracy.
Start at the beginning.
All right, next slide. We'll go later. All right, no, really, what you got to do is you have to solve a minimal amount. And for our experiment, we decided, all right, we're going to solve one of each letter and number for PayPal. So PayPal was this is what we want to beat with the automatic trainer. We solved one letter and one number from each. Thank you. So, yeah. So there's 31. They don't use the full letter and number spectrum. They only use 31 so we had 31 audio samples of each letter and number. 31 total, one of each letter and number. And so that got us 12% accuracy, which is hilarious that even that gets you any accuracy. But it gets 12, which isn't great, but it's not awful. So what you got to do is you split it up into 2 sets. There's because you can't train and test on the same sample set, because if you train on it, then you will obviously be able to test and get 100% on it. So you can't test on yourself, and that's something that's generic for all machine learning. If you train on these samples, you shouldn't test on them because you'll obviously be able to recognize them. It's like saying, let's have a Kevin Costner lookalike contest, and then you always pick Kevin Costner for the lookalike. Yeah, you can't really do that.
First, hang on. I got what? That is a fantastic thing.
Yeah, like you said, like we were looking at the data before when I had that ridiculously squiggly line. If you test on your training data, you're going to have a ridiculously squiggly line, and it's going to match. And it's not going to work overall.
Anyway, so because of that, we actually need to set up siblings. Sibling B, sibling A. You could actually have as many as you want, but for our test, we only had 2. So what you do is you download and split a lot of CAPTCHAs. You don't need to solve them by hand, you just need to be able to download them. So you download and split them, then you split that set into 2 sets, or however many you have per sibling. You have sibling A solve sibling B's CAPTCHAs, and sibling B solve sibling A's. Then you use those ones combined with the previous round's samples, and you train on them. And then you test against some known CAPTCHAs that you've already solved. We had to do 25 for that. And so if you get better accuracy, you just replace the current solver with you replace the previous one with the current one, and you just keep going through this. And so what you'll do is you solve a set with the opposite theta file, which is the neural network's source. Then you combine that with the parent, and you take the best CAPTCHAs that are the most certain that these are the correct answers, and then you train based on that, and you come back around and test, and if it's better, it just keeps going. So, next slide.
So the genetic algorithm was a bit of a interesting story because I'm sitting around, I'm out on my patio at my house, I'm smoking a cigarette, I'm thinking, so many times during the process of this project, we all have to take a step back and kind of looked at everything and say, we've focused too much on this, let's think about that. You know, fuck the background noise, let's do a fuck splitter, stuff like that. We're focused too much on something. And while I'm thinking and while I'm smoking and while I'm drinking, I have this little moment of clarity that I can't exactly put into words. So I instantly call Jeff Ball and we hash out this idea for doing the genetic algorithm. And we know that there's so much potential here because it saves us from having to listen to all that shit for hours and hours and hours and hours. And this is a tremendous diagram. I actually only saw this flowchart today, and it's spot on. It's perfect. We have the siblings. Oh, hang on. Priorities. I'm very happy with how this turned out, as we'll see on the next slide.
All right, so like I said before, we started off, each of the 2 siblings had just one example, a single example of each letter and number. So that's very few CAPTCHAs. We had to do 25 to test so that it could keep checking its accuracy and feedback into itself. But anyway, started off before with one sample, 12% accuracy. Afterwards, 48% accuracy. That's in the matter of 24 hours of it just training itself over and over again. So we no longer have to do 100,000 CAPTCHAs. We only have to do maybe 35. And so that's a very big improvement because it drives us crazy to do them. And so, yay for genetic algorithms. Oh, yeah. And we're releasing all the code. Go to that site. It's all there.
1, 2, 3, and 1, 2, 3 is
yeah, 1, 2, 3 is already there. This release with all of the random CAPTCHAs that we just talked about will be up there as soon as we get time to put it up later today.
Today.
Oh, yeah.
Seriously, Google, let's have some drinks. Because, come on. Questions, comments, complaints, fuck yous? Speak a little bit louder. I'm kind of deaf right now. Round 4? So the current round. Well, all right. So what we didn't mention was that in the first round, the background audio was reversed radio broadcasts. Yeah. So it was like initially audio recapture was to transcribe radio broadcasts, and apparently they abandoned that and just decided to use it for background noise. But it does sound like backwards, and it's backwards of the same speech-to-text system as they have forwards at the same amplitude. So it's pretty difficult to tell apart. We're running out of time, so quick question in the back. Comment. The Earls? Go back a slide. It's pretty easy. It's dc949.org/projects/Stillwalker. On the main site, there's a side nav thing, and there's HTML, and you can click on things called hyperlinks. Next question, comments, fuck yous, because we're just going to jet out of here. And I love you too, baby.
One additional comment for the guy over there that talked about it, the backwards audio. So in round 3, one of the hilarious things was it was just random phonetics for the background noise. And so what ended up happening is those phonetics sometimes align to hilarious audio. So one of the samples has beauty and death as the background noise. And
our brains are so powerful in a way that we want to find patterns and everything. And if you just align random phonetics, you're going to hear weird and scary things like the beauty and death. Quickly. Does it look like we're in it for the money? Why don't you buy us a drink and we'll talk? I don't know. I mean, is there someone from Black Hat here that can tell us how to make money? Because we just... A printing press. All right. Anything else? Anything else? I'm getting angry looks, so I got to go. Oh, we can keep going? Excellent. So, more fuck yous, please. Please. Fuck you. Fuck you.
Thanks, Iron Geek.
Iron Geek, if anyone does not know, does a tremendous fucking job at conferences doing the videos. Yesterday's videos are already online, aren't they? That's a tremendous thing. Round of applause. And he keeps getting better at it. Way better than anyone else who does this shit. Well, you know. So, I mean, we can just keep chatting. Who wants to come have a drink? Oh, hey, we need to find a volunteer who wants to be hit with smelling salts. Does anyone want to be hit with you? Pronto? Yep. Here we go. Yep. No, right now. We got plenty of time. It's in my bag, right there.
So what are some of the things that audio recapture can be doing to make it human?
I got this one.
So the question is, what is it that they could be doing better to, not fail so much?
Nothing. All right, so there is very little they can do to make it human understandable, but machine language not. If the words were longer, it might be slightly harder. Or if we couldn't gather as many, then it might be slightly harder, but that's about it. Audio captures need to be fundamentally changed in order to not be broken.
The only thing I could think of is if they used like palindromes or something that would be, basically if you take a sample of it and it'll be the same frequency forward and backward, it'll be 2 different words, and we'll need to give you different words, but they'll look the same if we take the average bass and thing. So that would be one way to do it, and we have some ideas on how to beat that if they did do that, and CP has something to say.
First of all, you know the word I'm about to say because I haven't said it yet. We could actually solve that with a little bit of minutia. If we shrink the sample size, we can just defeat that anyway. Question, comment, fuck you.
Just adding on to the discussion about like what could they be doing better. So like one thing I just thought of that they could do to fuck with people would be homonyms. There, and there. If they gave people like a sentence in context and they had to spell everything right. But nobody can fucking spell there, and there right anyway on the internet. So, I'm not sure how well that would actually work.
Absolutely excellent, because we didn't go over this. We went over this at the layer 1 slide. We cut so much content because we've never given the same talk twice, ever. Hands down, that's it. This is the closest thing we've come to giving the same talk twice. In the original round that we did, there was a problem where, how do you spell blue? B-L-U-E, B-L-E-W, B-L-L-O, B-L-U? Well, they all match. They all matched. And the slides that we cut are my favorite slides because we spent so much time developing word merges where one answer would validate against multiple challenges, including the word V-A-G. Oh, we have the old slides? Yeah, you keep doing that. Yeah. So there's one particular word, one of the first ones I came up with was the word V-A-G-N. Who could think of multiple ways to pronounce that word? All right, so vein. No.
Wrong.
All right, so like wagen. Wagen is pretty close to wagon. But also, in the English language, we have this wonderful thing called a silent G when it's in front of an N. It looks like van. So the word that we spelled V-A-G-N matched both wagon and van. So we shrunk. Yeah, the other one's great. Keep going, keep going, keep going. This is the layer 1 slide, so we're just going to... Thor's Day! So,
I am smart. S-M-R-T. I mean,
go back one.
S-M-A-R-T.
Go back one. Yeah. No, go back one. It's the previous one. One more. Where's the branch off slide?
I am
so this one.
smart. I am
so smart.
S-M-R-T. I mean, S-M-A-R-T.
So this is round 1. This is what we found. So you could combine words like fork and for to fork, and that word would match both fork and for. So we then had a solver that would say, if I'm confident it's this, but I'm less confident in this, it would just make a merge and submit that, and that would get it right. So spoon and teaspoon is really interesting because we have TS like tsunami, but also teaspoon. Seven, oven, seven. Here's a great. We started getting threefers because we developed a way to automate word merge finding, and we found wagon, and wagon matches one, van, and wagon. And of course, Friday matches Friday, ferry, and four. So we significantly reduced the key space of possible answers by just fucking coming up with merges. I couldn't believe this worked. Go back one slide. No. Academic papers come out in PDFs. We're all about flat HTML. So we're going to... Yeah. Go back. Oh, yeah, so brute forcing merges, that was fun, but we're not going to talk about that. So
I am smart. I am smart. S-M-R-T. I mean...
So, SMRT. Homer would have loved this because just who gives a fuck about the A? We found that sometimes vowels just don't matter in the initial round. So you could do spoon, and it would be that's spoon, but it's also SPN, spoon. And of course, I found that's actually an animated GIF that I found the day before our layer 1 talk, and it wasn't animated, and I was sad. But really, I mean, merging the words, it's almost like SoundX, but it's not quite. Because we thought it was SoundX, but it doesn't behave like it. Of course, now all of this is gone. They don't do any of this anymore.
That's why we cut it.
PJ.
That's why we cut it.
Oh, MD5. What do we, what, blah, 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 blah. Yeah. Holding on the line. Shh. Raffles in the bar. Raffle ticket. If you're not present, you don't win. I love you, baby. I'm not going to repeat that on the microphone. More question? No paying. Really? You're checking your phone while we're talking? It's just sad. You had a question. Oh. Okay. Do you want the mic too? Come on. Come on.
Come on up.
Come on.
Everyone else did.
Come on, clap, and we got plenty of time, apparently. Come on.
I was just saying that the one thing that is the hardest to replace probably is the context that a human can figure out and loud enough. The context is that a machine could not figure out. So the minute you would probably pose an example that's, without the background noise or whatever, pose a question and the answer would be easy to give as an answer to the capture, then that is an improvement that's very hard to break. Thanks.
So the question was, well, all right, the question / comment or input was, well, why couldn't the CAPTCHA just ask a logical question that a computer wouldn't be able to solve too easily, but a human would? First, the response to that is there's Dr. Watson, the Jeopardy computer that won Jeopardy. And also, you have to have unlimited samples. That's also, otherwise you could get it, solve it, and then just record the answer. But there's actually a good paper we saw on logical CAPTCHA. called Eggbot. Eggbot posed the question. Yeah, Eggbot posed the question: fork blank food, and something like eat with would be the answer, and you'd have to fill in eat with, or shovel blank hole. So the answer would be shovel makes hole, and so you'd have to fill in makes. And so Eggbot was this type of logical CAPTCHA that you're talking about. What they actually found is that with 35% accuracy, they could search Google, use the phrases found by Google, and that would be 35% accuracy. This wasn't us, this was another paper. But the other finding, which is much more hilarious, was that if you use the word make, because make can mean pretty much anything, you'd get 96.5% accuracy. You answer every CAPTCHA with the word make, and you're almost always right. And so that was a poorly designed one, but the Google solver is kind of, or Wolfram Alpha, they all can be used to beat logical CAPTCHAs.
So, is it an improvement? Yes.
Yeah.
Yeah.
You want to talk about economics?
Economics. Who wants to learn about CAPTCHA economics? Is anyone interested? 1, 2, please just raise your hand. We'll just keep talking the whole day. All right. CAPTCHA economics. Adam, because you read that paper, I skimmed it.
Again, this wasn't our paper, but...
I read a paper on the economics of CAPTCHA breaking, because I'm like, well, I mean, we're not the only people doing this, right? I mean, I've gotten a lot of spam, so I've seen this stuff before. And turns out the cost of breaking 1,000 CAPTCHAs is about $1. Their accuracy is actually surprisingly good. It's about like 90-some-odd%. The reason that is because they're using humans to solve it. And in some cases, we've actually done better than the slave labor humans. So that's entertaining. What else about economics?
Macroeconomics.
How much do they actually give to the CAPTCHA solver?
What?
How much do they give to the actual CAPTCHA solvers? 75%?
Like death by recapture, if you're a solver, how much you make?
Oh, they are. By the way, some of them have their own, private, office in some foreign country that, you just have a bunch of people that will give you food and a place to, sleep, and you do work for us. And that's kind of how they work. Other systems will have quote-unquote volunteers, where if you solve 1,000 CAPTCHA, you get paid 50 cents or maybe 75 cents, and they're charging $1, so they just take the difference.
Sure makes our 15 million that we solved of round one look good. So, would have been a decent amount of money.
I did some math, by the way, during round one when we were solving CAPTCHAs 24/7 in order to get unique CAPTCHAs. And if we had sold the service for the same price as Death by CAPTCHA, it was something like $200,000 a year. 'Cause that's boring. I don't know. I think we're done. We're drinking. Questions, comments? Yes. Oh! I'm so glad you asked this.
You gotta say it this way, man.
What? Huh? Oh, okay.
Do you want to play a game?
Library. So, there's a bit. The question was, how do we feel about the game, the CAPTCHAs where you have to play a game? Like park the red car in the parking space, put all the food in the refrigerator, put all the objects that belong on the ground. You put the helicopter on the ground. I was like, no, fuck you. Helicopters don't go on the ground. They fly.
First of all, tell them about the flyback.
I will. So here's the fantastic part. There's the main one, and I forget the name. Do you know the name? I know. Well, he'll look it up, but I forget the name. Well, the fantastic thing about that CAPTCHA is, well, they also use an audio CAPTCHA provided by reCAPTCHA. So we didn't even bother with them because we already had them. However, that being said, that is a very novel idea because it's not just drag it into the place. They do some playthrough. Yeah, playthrough is the name of it. So what's interesting is they you can automate this. There's macros, like some guy made in a MacBook. He's like, this is how I'm going to show you the thing. And he did it. It was great. Except that sometimes he'd be caught as a bot because of how he dragged the boat into the ocean, because it was rigid, and it's not how a human would do it. So they so this is a really cool system, but they use reCAPTCHA for the ADA compliance, and that's audio, and that's fucked, and that's done with. But the idea of running a game, like, put the pancake on top of the shoe. Yeah, so remember round 4? Welcome to round 4 again. Am I seriously the only one? Yeah. I hate to be outsmarted by CAPTCHAs. I hate CAPTCHAs, that is all. I actually monitor Twitter for complaints against reCAPTCHA because it's so funny watching them bitch about the audio. The thing? So if you go to the Google groups for reCAPTCHA, there's a tremendous amount of complaints that we spoke about earlier, but one in particular was put together very well, and he made a fantastic statement. Let's see if we can pull it up here. The statement's just amazing. Yeah, that's it. So at the bottom, he makes this very passive aggressment. That's fine. Perhaps the audio capture is not designed for use by humans. So that I love reading that. We done? Good? Excellent. So the next speaker's here. Thank you so much for letting us run over time and drinking in front of you for no fucking reason. I hope you guys enjoyed Stillwalker. We had a tremendous amount of fun doing it, and apparently it's going to be easy for us to keep doing it. So stay tuned. End of line.
Nope, we're done. That's it.